Hey guys, so as you can tell, I am not here. I am at volleyball today. So I am either currently running a warm-up or hopefully winning against Governor Simcoe. So me not being there means that I'm not necessarily ready I'm not necessarily there if you have any questions to get you ready for the test on Monday. I'm going to run through with you right now just two homework questions that I gave you. These homework questions are very representative of things that I could ask you on the test on Monday. So don't forget the test is on stoichiometry, it's on limiting and excess reagents, and it's on percent yield as well. So first question that I want to run through with you is on page 300. It's number 19. So I'm going to read through it with you very quickly. This is an example of just a very simple, basic stoichiometry question. This is going to be really the basis of the test on Monday. So page 300, number 19 reads, silver tarnishes when it is exposed to small amounts of hydrogen sulfide, H2S, in the air. 4Hg plus 2 hydrogen sulfide plus oxygen gas yields 2 silver sulfides and 2 water molecules. How many molecules of hydrogen sulfide would react with 1.7 moles of silver? So all I've done up until this point is I've gone ahead and I've given you here the balanced chemical equation. How I got that? Copied it from the question. So this balanced chemical equation was actually given to you in the question. Oh, we missed a 4 here. All right. So you just want to go through, you just want to make sure that this really is balanced. 4 silvers on the left, 4 silvers on the right, 4 hydrogens on the left, 4 hydrogens on the right, 1 sulfur on each side, and you have 2 oxygens on each side. So we can go ahead and proceed. So now remember, this is a stoichiometry question, so we are going to have to give you a little bit more info. So that last line of the question reads, how many molecules of hydrogen sulfide react with 1.7 moles of silver? So all I'm going to do is I'm just going to go through and I'm just going to underline what the question is giving me information about. It's telling me that I have 1.7 moles of silver. So it's giving me information about silver. What is it giving me? It's giving me number of moles. So typically a lot of the questions that I've given you have given you mass. This is giving you number of moles. That's just saving you a step. So number of moles is represented by little n. How many do I have? 1.7 moles. The question then asks, how many molecules of hydrogen sulfide react? So hydrogen sulfide is right here. What are we looking for? We're looking for number of molecules. Again, in the past, I've asked for mass. This time I'm asking for number of molecules, which is represented by big N. Okay, so essentially oxygen, silver sulfide, and water we can ignore from this point on. We're just dealing with the ratio of silver to hydrogen sulfide. So let's go ahead and proceed. So how we would normally do this question is we would normally have to convert from mass down to number of moles. Do I have to do this time? No, because we already gave you the number of moles. So N is equal to 1.7 moles. So next step that we always do is that lovely molar ratio, right? So the molar ratio, what I'm doing is I'm comparing information about the element I was given, and I'm comparing it to the information for the element that I'm seeking. So in this case, we gave you information about silver up here. So what's the big number in front of silver? What's the coefficient in front of silver? 4. And what am I looking for information about? I'm looking for information about hydrogen sulfide over here. So what's that big number in front of hydrogen sulfide? It's a 2. What am I looking for? Number of moles. Well, do I know number of moles of silver? Yes, it gave me in the question. I know I have 1.7 moles of silver. And I'm looking for the number of moles of hydrogen sulfide. So now all I'm going to do now is I'm going to go ahead and I'm going to cross multiply. Okay? So I'm going to do 1.7 times 2, and I'm going to do 4 times n. So what's that going to give me? I'm going to have 4 moles of hydrogen sulfide is going to be equal to 1.7 times 2, which is 3.4. Then I'm going to go ahead and divide 3.4 by 4. It's going to cross this guy out. And I'm going to find out that my number of moles of hydrogen sulfide is equal to 0.85 moles. Okay, so now I'm here. I know that N of hydrogen sulfide is equal to 0.85 moles. Am I done? Of course not. So now I want to give the amount of hydrogen sulfide that I have. I know I have 0.85 moles of hydrogen sulfide, but the question asked for what? The question asked for how many molecules of hydrogen sulfide that I'm going to gain. So for this, we have to consider our triangle. We're not considering the mass triangle this time. We're considering the number of particles triangle. So we know that the number of particles is equal to the number of moles times Avogadro's number. So I know from this triangle, I'm seeking big N. So I know that big N is equal to 0.85 moles. And I'm going to go ahead and multiply that by Avogadro's number, which is 6.02 times 10 to the 23. If I plug that into my calculator, I'm going to find that N is equal to 5.1 times 10 to the 23. And what is that? That's molecules. I'm dealing with 2 nonmetals. So I'm dealing with a covalent bond, molecules. So I can go ahead and write a nice therefore statement. Therefore, what do we give you? 1.7 moles of silver yields, sorry, not yields. Let's get rid of this. Reacts with 5.1 times 10 to the 23 molecules of hydrogen sulfide. Is that your final answer? Did you answer what we were asking you for? Did you tell me the number of molecules that hydrogen sulfide reacts with? Yes, you did. Awesome. Okay, next question. All right, so the next question that I gave you, and this is a wonderful long answer question, right? So this is one that's going to require multiple steps, okay? This question was 332, and it was number 18. So I gave it to you 2 days ago. I put a star next to it, and I said I was going to take this one up in class. So that's page 332, number 18. So let's go ahead and let's go through and read the question together. So the question states, what are the theoretical yields and percentage yields if 14.59 grams of iron 2 chloride, FeCl2, and hydrogen gas are produced when 6.51 grams of iron reacts with excess hydrochloric acid? Okay, sounds like a mouthful, but let's go through and let's dissect this. Let's figure out what information we gave you. So reading the question, first thing we should be looking for is a balanced chemical equation. So in the question, it says that iron reacts with excess hydrochloric acid. So let's go ahead and let's write this as an equation. We know that we have iron, Fe, and it's reacting with hydrochloric acid. What is that going to yield? Well, the question says that FeCl2, iron 2 chloride, and hydrogen gas are produced. So in this case, we have FeCl2, let's make that look more like a C, and we have hydrogen gas. So that's what's produced. Now, next thing that we have to do is we have to go ahead and let's make sure this equation is balanced, right? Remember, you have to make sure your equations are balanced. Otherwise, that molar ratio, that second step in stoichiometry, is going to be off. So I have 1 iron on the left. I have 1 iron on the right, so I'm good there. I have 2 hydrogens on the left, and I have 2 hydrogens on the right. So we're going to go ahead, we're going to put a 2 in front of HCl. Okay, now I've got 2 chlorines on the left, and I've got 2 chlorines on the right. So I am good to go. Okay, so now let's go ahead and let's see what information they gave us. So they gave us the actual yields. We're not going to deal with the actual yield right now because the first thing you want to do in this case is you want to go ahead and you want to figure out the theoretical yields. So to figure out the theoretical yield, we need to figure out which one is the excess and which one is the limiting reagent. Remember, you only want to use the limiting reagent to determine theoretical yields. If you use excess, your theoretical yield is going to be too large. So if we actually read the question carefully, the question says that 6.51 grams of iron reacts with excess hydrochloric acid. So they actually saved us that whole first step, that whole first chart. They told us that we have excess hydrochloric acid, so that means that this is the excess reagent, right? Do we have to worry about it then? No, right? So we automatically know that iron is going to be our limiting reagent, right? So we want to deal with the mass of iron. In the question, it tells us that we have a mass of iron, M, is equal to 6.51 grams. Okay? What are we trying to seek information about? Well, we are looking for the theoretical yields of FeCl2. So we're starting with iron. They gave us information about iron, and we're looking for FeCl2. So we can essentially, once it's balanced, we can essentially ignore hydrochloric acid and hydrogen gas in this case. Other pieces of information that we're going to want to grab while we're here is we're going to want to go ahead and grab the molar masses of iron and the molar mass of FeCl2, iron 2 chloride. So the molar mass of iron, that's an easy one. I can read it right off the periodic table. And I am going to see that my molar mass of iron is 55.85 grams per mole. My molar mass of iron 2 chloride, a little bit more difficult, right? So I have 1 iron and I have 2 chlorines. So I'm going to go ahead and I'm going to take my mass of 1 iron, which is 55.85, and I'm going to add to it 2 times 35.45, that's my mass of chlorine, and that is going to give me 126.75 grams per mole. Okay, Awesome. So now we're going to go ahead and we're going to work through this, right? So we are going to do our 3-step stoichiometry. So in the last one, I did the graphic organizer, right? Remember, half the class likes the graphic organizer, half the class likes the step-by-step procedure. So for this one, I'm going to go ahead and give you the step-by-step procedure. So the first one that I'm going to do, my first step, is I have to go from mass to moles. So let's go ahead, let's consider our triangle. So we know that if we are looking for number of moles, we need to take mass and we need to divide it by molar mass. So in this case, I'm going to take number of moles is going to be equal to mass divided by molar mass, which in this case, my mass is 6.51 grams. My molar mass is 55.85 grams per mole. Those grams are going to cancel out. And I am going to be left with N is equal to 0.12 moles. So I know that I have 0.12 moles of iron. Perfect. Okay, so let's go ahead. Let's do our next step. We can get rid of this guy here. And our next step that we want to do is that molar ratio. So I'm going to go ahead and do the molar ratio. So how do we set this up? Well, first thing we have to do is we have to look at what we were given information about. That was iron, right? So the big number in front of iron, if there's nothing written in front of iron, we assume it's a 1. So we've got the coefficient of 1. And we are looking for information about iron 2 chloride over here. So again, if there's nothing written in front of it, we know it's a 1. So my favorite, better than a Christmas present, is a 1-to-1 ratio. So in this case, we know that we have a 1-to-1 ratio. How many moles of iron do I have? Well, I just calculated. I have 0.12 moles. And I am looking for the number of moles of iron 2, oh geez, that doesn't look like iron, iron 2 chloride. 1-to-1 ratio, we know automatically that our number of moles of iron, better iron this time, 2 chloride is going to be equal to 0.12 moles. Beautiful. All right, so we know that we have 0.12 moles of iron 2 chloride. Are we done? Of course not. We have to do our last step. We have to go from moles back to mass. So remember, we do mass to moles, molar ratio, moles back to mass. So I am quickly running out of space here. So I'm going to go ahead, I'm going to erase this left-hand side here. I'm going to leave the molar ratio on the right for some of us that are still checking our work, because of course we all did our homework, so we're not copying this down like mad people. We're just checking our solution to make sure that it's right. And now we are going to go ahead and we're going to go from moles and we're going to go back to mass. So to do that, I need to consult my handy dandy triangle. And my triangle is telling me that if I am looking for mass, I'm going to do molar mass times number of moles. So mass is equal to molar mass times number of moles. Well, lucky for us, we went ahead and we calculated the molar mass of iron 2 chloride already, and we've already calculated the number of moles. So I know that mass is equal to 126.75 grams per mole times 0.12 moles. These moles here are going to go ahead and they're going to cancel out. And I am going to be left with 126.75 times 0.12, which is going to give me 14.77 grams. So we can go ahead and write a nice therefore statement. Therefore, now we have a mass, that's awesome. We have the mass of iron 2 chloride, right? Let's not forget what this question was asking for. So it was a two-step question. The first thing that it asked me for was a theoretical yield of iron 2 chloride. So that's what we calculated now. So therefore, the theoretical yields of iron 2 chloride is 14.77 grams, right? Beautiful. Now, are we done? Of course not, because I wasn't looking for just theoretical yields. I was looking for actual yields, right? So let's go ahead. Let's give ourselves some space. I'm going to go erase this. We don't need this balanced chemical equation anymore. We used it. That's good, right? So while I'm erasing it, let's think about the relationship between actual yields and between theoretical yields. So in the question, they gave you actual yields. Actual yield is very similar to the precipitate lab that you just did. It's how much you actually get in a chemical experiment, right? So if you're in a lab, how much product do you actually get? That's your actual yields. Your theoretical yield is a best case scenario. It is theoretically, in a perfect world, how much product should we get, right? We know that between experimental error, which we went through and listed lots of the experimental errors that you can make in a lab, and we also know that because of competing reactions, the theoretical yield is not always equal to the actual yields. So what is that relationship? The relationship is, oh geez, that is not a P, Miss Kropac. That is a P. There we go. Percent yields is equal to actual yields divided by theoretical yields. Okay, so your actual yield should always be smaller than theoretical yields. I say always with the pause because some of you had your actual yields larger than your theoretical yields, but you shouldn't ever be having a larger number for actual yield. It should always be a smaller number. So where do I get this actual yield from? I get it from the question. It gave it to me, right? So when I read number 18 from the textbook, it says that 14.59 grams of iron chloride was produced. So my actual yields is equal to 14.59 grams. My theoretical yields, I just calculated. So I just calculated my theoretical yield to be 14.77 grams. So to plug this in, I'm just going to go ahead. I'm going to take my actual yield divided by my theoretical yields. So I've got 14.59 divided by 14.77. That is going to give me 0.9878. But remember, I'm looking for a percent. So I always want to multiply this number, this decimal, by 100%. And that is going to give me a percent yield of 98.78%. So we can go ahead, we can erase this old therefore statement. I just kept it there so we could have our theoretical yields right in front of us. And we can write a new therefore statement. Therefore, the percent yields of iron 2 chloride is 98.78%. Good, awesome. All right, guys, so that is the end of our homework questions. So just a couple things I want to touch on before I go. Your assignments, your assignment 2, there's many of you that did not submit it, which is unfortunate, but at the same time, we still do need to get feedback back. So I was at the school this morning, no one was here, I understand it was 7 a.m., I will be back in the school today. However, depending on how we do in the tournament, that could be anywhere from 3 until 6. I'm assuming I'm not going to find many of you at school at 6 p.m. on a Friday night. So I will be at school early on Monday if you want feedback on your assignment before you write the test. Or easiest way to get a hold of me if you are very concerned about how you did on the assignment and you want feedback for your test, email me this weekend and I will give you any problem sections that you need to work on, all right? Remember, you're doing the review. The review is the most representative questions that I can give you for the test. So if you were okay with the review questions that we just took up now, you're probably going to be okay for the test on Monday. Remember, it's just on 3 concepts: stoichiometry, limiting and excess reactants or reagents, and percent yields. So you can go ahead now. You're going to work on those review questions that I gave you. If you would like, I put some additional review questions on the board here. So if you are done, you can do page 334, number 12, number 15, number 22, and number 25, okay? Also, just a note about your lab. Your lab is going to be due on Tuesday. So the precipitates are dry. They are downstairs. Many of you weighed them after the test or when you were doing your review the other day. If you did not weigh your precipitate, please make sure you do so on Monday. Your lab is due on Tuesday. I want you guys focusing on writing your test, not on doing your lab report at this moment in time. Those of you that missed the lab, I know Theron, Wyatt, Kanan, you guys were all at hockey. Anyone else that missed the lab, your makeup is going to be on Tuesday as well. So we'll get the makeup done for the lab. You can have your precipitate dry and you can get it handed into me before Christmas break. So good luck on your test, guys. Any questions, you know how to get a hold of me. I'm sure you will do fabulous. Wish us luck. Hopefully we come back with winning t-shirts and we will see you guys on Monday morning. Bye. One last thing that I forgot. Tests. For the most part, we did actually really very well on the tests. Very few of you were totally lost, which is awesome. That's what we were looking for. If you want to know your mark on the test, they should be marked by Monday. I am probably currently hiding under bleachers right now, marking them. Just a reminder too that your test on Monday is on stoichiometry, limiting reagents, and percent yield. That being said, these triangles here, we just went over 2 examples where you still needed to know how to use these triangles. So is this a focus of the test on Monday? Absolutely not. That being said, this stuff doesn't go away. So there's going to be no just mass, molar mass questions. There's going to be no just number of particle questions. You do have to know those to predict the amount of product in those stoichiometry questions. So be sure that you know these triangles for Monday's test as well too. Okay, bye for real this time. Bye.